So what is the electric flux through that surface? So we are going to, these are all electric fields, right? Just to be sure, yeah. And the electric field has a strength of 200 newtons per coulomb. Actually, I think that's a scalar. Yeah, because they didn't give us a regular, you got to do correction in that. Okay. So 200 newtons per coulomb at an angle of 30 degrees to the surface. So then the flux should be something like E A. Okay, E A cosine, and I don't want to use. Oh, I can't do that. So I'll use psi, because that's psi. All right, because we use the angle to the perpendicular, not the angle to the surface.
Why are we using
Because,
psi?
180 minus theta. Oh, because it goes into it. I mean, wouldn't it just make it negative? Yeah, you know what I mean? It just. So William's point is an intriguing one. He's saying because it's going down, we have to use like this angle or something, right? Like or this one, like that 90 plus theta. I would just rather know which direction it is, use the smaller angle, and then just say, okay, it's down or up. But that's fine. Yeah, I mean, that's more rigorous, so that's good. Yeah.
Why do we use
Yeah,
I
so-
know, but why is it?
Because what was the reference? What is the thing that tells us about the surface? Is it literally the scalar measurement of the area? No, because that doesn't tell you where the surface is pointing,
Oh,
right? We need to know where the surface is. We need to have,
the direction.
yeah, the direction. And the direction is caused by the area vector. Is demarcated by the area vector. So you always have to go with that. Questions from that? Everybody cool with that?
What's that?
Which letter?
The fourth one.
Oh, that's psi.
Psi.
Yeah.
Can we just use sine theta?
Yeah.
Like psi. Isn't that the same thing as cosine?
Intriguing. Okay, so mathematically, obviously, they're the same, right? Because everyone here is okay with the fact that sine theta is equal to cosine phi, or psi, or whatever I just said. Can you do that? All right, if you were like, okay, well, if you know that, why is it that big of a deal not to do, or to do this? I would say you should probably get into the habit of doing this, because I don't want you to connect, because remember, in reality, that means dot product. And dot product means use the components, multiply the primary vector by the collinear components of the secondary vector. That's what this is saying, right? Huh? Isn't it cosine? Yeah. Right, like if E is this way, and then A is that way, I want the part that's flat, right? So I use cosine. And then, of course, the cross product being the perpendicular component. So it's one of those things where if you did it on a test, and it would put it in question. I'd be like, okay, does that person really know? Are they just cutting a corner? Because I don't think it saves you any time. Yeah, so I would say definitely remember that that's cosine. Yeah.
I'm still not sure why we're using sines.
Oh, in the book, well, not in the book, but in general, when we're using this, right, that phi is this, we need the part of, it's kind of like we need the part of the electric field that is perpendicular to the surface, right? And then, so that means, yeah, whatever, if we go underneath this, right, it means that angle right there, which is,
Wait, if it's like perpendicular
Yeah, yeah. If it's perpendicular, because what's cosine of 0? 1, right? I mean, that's ultimately the interesting issue, right? Like if I draw this surface and I say E is coming like this, E is coming straight down. So this is perpendicular. If you use sine, that is problematic.
Oh,
You have to use cosine. Because cosine of 90 is 1, right? And that means all of E is penetrating that area. Everybody cool with that? You good? Okay.